Welcome back to another STEM with Miss Dubois video. In today's video, we are discussing simple machines. What is a simple machine? A simple machine is something that makes the amount of work something or someone does easier. And there are 6 types of simple machines. There is the inclined plane, the wedge, the screw, the lever, the pulley, and the wheel and axle. But before we get any further into the video, let's focus on this bolded word, work. And that is because it is a key part in understanding simple machines and why we have them. So, what is work? Work is how much energy it takes to move an object. And there's an equation for it, which is work equals force times distance. But this is a complicated equation, so let's break it down. Work is measured in joules. Joules is the unit for measuring energy. And joules can do this because work is the act of moving energy from one object to another. Basically, you're measuring another idea of energy. Force is a push or pull on an object, and it's measured in newtons. Distance is how far an object moves, and it's measured in meters. Now that we've broken down the work equation, let's rephrase the definition of work. Work is how much effort it takes to move something. Effort is the energy, which is shown in joules, and work is measured in joules. Moving something requires a push or a pull, no matter how you do it. And that is the definition of force. How far something moves is the distance. So you might be wondering, how can we tell if a simple machine works? We can do that by determining the simple machine's mechanical advantage. Now, you might be wondering what the heck a mechanical advantage is. Basically, it's how effective a simple machine is at making work easier. So, when a simple machine is used, it poses the question, would this task be easier if this simple machine didn't exist? Now, how do we measure that? Well, there's an equation for it. Duh. This is a physics topic, and physics loves equations. I wish I was being sarcastic, but I swear I'm being very genuine right now. Physics does love equations, and this is a physics topic. So, what are the equations for a mechanical advantage? Well, every simple machine sort of has its own equation, but they all equal these 2 equations because there's actually 2 types of mechanical advantage: the ideal mechanical advantage and the actual mechanical advantage. Ideal mechanical advantage equals input distance divided by output distance. Input distance is how far or how much you move the machine. Output distance is how far the load moves. The load is the object or thing that you are trying to move. As for the actual mechanical advantage, that equals output force divided by input force. Output force is how much force the machine applies to the load or the thing you are trying to move. Input force is the force you apply to the object. There are pros and cons to both equations. For the ideal mechanical advantage, the pro is that it's easier to calculate in a lab, and it can be calculated in advance. The con, however, is that it's not realistic for the real world because it doesn't include things like friction or resistance in its equation when those 2 things are very, very real in the real world. For actual mechanical advantage, the pros and cons are opposite sort of in terms of how they work. And you'll see this in a second. For actual mechanical advantage, its pros are that mechanical advantage is more accurate in the real world because it includes things like resistance and friction in its equation. However, its cons are that force can be difficult to calculate in a lab without proper equipment, and you can't calculate actual mechanical advantage in advance. You have to do it after collecting data. So you might be thinking, Ms. Dubois, you didn't answer my question. I'm still wondering, how can we tell if a simple machine is effective? Well, you have to use those equations to calculate if a simple machine is effective for you. In some way or another, all of the equations I mentioned still kind of follow this rule. If the mechanical advantage is greater than 1, the machine applies more force to the load than you do. The machine does more work to the actual object than you do, basically. If the mechanical advantage is equal to 1, there is no change in force, just a change in direction or distance. If the mechanical advantage is less than 1, you need to put more force on the object, but the task gets done faster. Remember, mechanical advantage is how effective a simple machine is at making work easier. That leaves some room for debate on what you, the engineer, thinks is best. And that was today's video on simple machines. I'm STEM with Miss Dubois. Thanks for watching. I hope you have a great day and a great life. Bye!